Welcome to the class of medical physics in the domain of electromagnetic radiation, electromagnetic spectrum. We are continuing with the topic of light. We have discussed about the laws of light, and today we are going to start about the practical application of the reflection of light from mirrors. And particularly today we have spherical mirrors, including the convex and concave mirror. These spherical mirrors are, of course, a part of a sphere which is being polished from inner surface to the outer surface. So one of those curved surface is become a reflecting one. The curved mirror is a mirror with a curved reflecting surface. Due to that spherical formation or the surface of that mirror, right? So the surface may be either convex or concave. Most curved mirror surfaces that are shaped like a part of a sphere and are used in optical devices. Basically, we do have plane mirror, but the need for spherical mirrors is considered to next level, because in plane mirror you can easily find out your appearance as upright in same size with the equal distance of image and object. So when it comes to the need where we need to enlarge the image, where we need to diminish the size of image, we go for spherical mirrors. We go for concave and convex mirror. So coming towards their formation, we do have a part of a sphere, a transparent material. So it depends upon which surface you are going to be polished. That mirror will be formed according to that polished surface. If you are polishing your hardcore surface from outside of the the mirror or spherical side, from outside, if you're polishing, that mirror will become a concave mirror because its reflecting surface is going to be the inner one. The inner one, which is a cave like shape, is going to become the concave mirror. If you are polishing or somehow hiding one of the surface of a spherical mirror, the inner surface specifically, and denoting it as hardcore surface, the outermost curved surface is going to be the reflected one, right? This will become the shiny or reflecting surface, and that type of mirror is known as the convex mirror. Okay. Other than that, we have few terminologies related to that mirror. If you just notice, let me draw it for you. This is okay. If you just consider, I don't know how I am going to draw it completely. My bad. Okay, just try it again. Just complete the circle. We need to just complete the circle in the form of a sphere, for example. Okay, just consider it as a spherical surface, and you have picked up this much amount of a sphere for your mirror, for the formation of mirror. So obviously, for this sphere, there must be have some center point of that sphere. That center point is known as the center of curvature, and we denote it as 2f. F is for the focal point of the mirror. What is the focal point? The question is that focal point is the equidistant or equal distance of center of curvature to the pole. This is the center of, this is the pole point, center of the mirror. So the distance from pole to the center of curvature is known as your sorry, the distance, the half of the distance of between the center of curvature and the pole is known as your focal point, f. So if because this is these two distances before the focal point and after the focal point are equal, that is why the center of curvature is denoted as the 2f, because from pole to the focal point, the distance is known as the focal length. And if you double the focal length, because if this distance is focal length, the similar goes from focal point to center of curvature, the distance is equal. That is why we represent the center of curvature as 2f, right? So we do have these two terminologies, um, and few others. Okay, let me show you all of them in next picture here. Okay, you have same concave mirror, you have similar convex mirror. The line passing through the center of that mirror is known as the principal axis. The distance with pole of the mirror to the focal point is known as the focal length. The center of curvature, which is equidistant or half of the focal point is basically half of the center of curvature to the pole distance. That is why center of curvature is denoted as 2f. But in case of convex mirror, although we know that the reflecting surface is the outer surface, light is coming from this side, and you are going to see the picture from this side of the mirror. Even after that, the focal length and center of curvature is going to be the curved side, curved inner surface of the mirror. Obviously, if you just consider and complete this is sphere, the center of curvature of this sphere will be inside of this surface, like the curve inside surface of this sphere. That is why the focal point and center of curvature is to the opposite side of the reflecting surface of convex mirror, right? And the distance again from surface of the mirror, which is pole, center surface of the mirror, to the focal point is focal length, and center of curvature is twice of the focal length, right? Next is to discuss about the properties of concave and convex mirror, why they are differentiated, and what is the difference among them in image formation. Concave mirror is a hollow sphere is to be cut into parts and the outer surface of the cut part is painted. Then it becomes a mirror with its inner surface being a reflecting surface. This type of mirror is known as concave mirror. You have characteristics of concave mirror. Light converges at a point when it strikes and reflects back from the reflecting surface of the mirror. Hence, it is also known as a converging mirror. All the light rays through concave mirror are going to be converged at one point because of its shape. It will converge all the light at one point and known as a converging mirror. When the concave mirror is placed very close to the object, a magnified and virtual image is obtained. Magnified, a zoomed image, an enlarged image is going to be formed if you place the object very closely to the concave mirror. However, a virtual image will be obtained. We have two types of image. We will see in next slide probably that there are two types of images, a real one and a virtual one. So whenever you are going to get a virtual image, that image will be inverted in nature. Okay. However, if we increase the distance between the object and the mirror, then the size of image is going to be reduced gradually and a real image is formed. The image formed by concave mirror can be small or can be large and can be real or virtual. It depends upon only of the distance between the object and the mirror. Depending upon the distance of between the object and the mirror, the image will be likewise, whether it will be virtual or it will be the real. But it is completely indicating that if you just go far away from the mirror, the size of the image is going to be reduced and real image will be formed. And as much as you will go closer to the mirror, the size is going to be the magnified and virtual image will obtain. Next is your convex mirror. If the cut part of the hollow sphere is painted from inside, then its outer surface becomes the reflecting surface. This kind of mirror is known as convex mirror. Characteristics of convex mirror. A convex mirror is also known as a diverging mirror because light is going to be diverged when it is going to be strike from outer surface of the mirror, outer reflecting surface of this convex mirror. It is going to be diverge in different direction. Due to that, virtual, erect, and diminished images are always formed with convex mirror, irrespective of the distance between the object and mirror. You always have diminished images from convex mirror because the light rays, the reflecting light rays are going to be diverge in different directions. So you need, so the image will form behind the mirror, which is going to be the virtual, the erect, and a diminished image. Next, what is the difference between a real image and a virtual image? A real image occurs when light rays actually intersected the image. When do we have real images? When light rays actually intersect at the image and is inverted or upside down. It is formed due to actual intersection of the rays. Okay, whenever you do have image formation or image ray diagrams, we always consider object at uh, and denote that distance of object with the mirror as object distance. When you go for the ray diagram for image formation, we do need to pick up or draw at least two rays for image formation. At least two rays are required, minimum. Those these two rays are always going to be reflected on the mirror, are always going to be incident on the mirror from the head of the object, from the top of the object. So you can see one incident ray is incidenting on the mirror at the point of pole. So it says that when a ray of light is going to be incident at the point of pole, it will reflect back with the same angle by fulfilling the law of reflection of light, which says that angle of incidence is equal to angle of reflection. So the angle with which it is incident, the light is incident on the mirror, on the surface of mirror, because this is the center point of the mirror, and the center point fulfills the law of reflection. So the light is going to be reflect with the same angle. This is the principal axis. If you just measure the hold on. If you just measure the angle of incident of light ray from with principal axis, which is actually the normal for this mirror because it is at 90 degree with the mirror. So you will find the angle of reflection with the same angle if you just measure it. For the next ray, the ray is emerging from again top of the mirror, but it is striking at the surface of mirror by passing through the focal point. If a ray, if an incident ray is passing through the focal point and is reflecting at the point of mirror, it will go parallel to the principal axis. The ray, the reflected light ray will be will go parallel to the principal axis after reflection, right? So where at the point where these two light rays are intersecting each other, the image is going to be formed right at that point, and you can see the image at that point, right? As you can see after this ray diagram, when the object is placed between the focal point and center of curvature, and whatever wherever the image is forming, the height of the image is, or the size of the image is more than the size of the object. This is the benefit of a spherical mirror. You can have an enlarged image of the object, but the image is inverted in this case, upside down, because wherever or whenever you place any object on principal axis, the and you have the intersecting reflected rays at that point, if you are starting the rays, emitting rays From top of the mirror, you are, wherever the rays are intersecting, the reflecting rays are intersecting, you have to draw the head of the object at that intersection point, because you are starting from the head of the object. The rays are emitting from head of the object, so wherever it is they are intersecting, that will be uh, the head of the of the image. So accordingly, the bottom of the object, the base of the object is at the principal axis. Your image base or your image bottom will be connected or will be locate at that point of principal axis. The bottom of the image will remain associated with the principal axis. That is why you have an inverted image. Okay? You have an inverted image but in upside down form. All right. Then what is virtual image? Virtual image occurs when light rays do not actually meet at the image. Light rays do not actually meet at the image. Instead, you see the image because your eye projects light rays backward. A virtual image is right upside. Whenever you have a image from a plane mirror, you always have a virtual image. Only because of that, you do not have a real time image, but your eyes project the light rays backward. What does it mean? If you just consider this example again, you have two light rays emerging from the top of the object. One is going parallel with the principal axis, another one is reflecting at the pole point. The reflected ray is going to be the incident ray, which is hitting the at the point of pole, is going to be reflected with the same angle. The law of reflection is fulfilling for this ray. Whatever the angle of incidence, you have the same angle of reflection. All right. But for the next ray, as we do need to draw two different rays in two different directions, so the next ray is, for example, going to be parallel with the principal axis. Because this is a convex mirror, it has a property to diverge the light rays due to its uh, outer spherical surface. The light ray will be diverged into some other direction. As you can see, this second ray is diverging and this first ray is also diverging. They are not going to be meet, or they are not going to be intersect at any point because they are divergent in opposite direction almost. So what to do for the image formation? We all we have is to project back the light rays, the reflected light rays in opposite direction, where they can meet in a virtual scenario. They will be meet at a point, and at that point of intersection, we do have the image of that object. Now, from intersecting point till the principal axis, whatever the size is, that size will become the size of the image. And because this is on the same side of the object, which is because if you just see, know that the object is on the upside of the principal axis, and the intersecting point of these virtual reflected rays are also on the same side of principal axis. The image formation is known as the upright or erect. So whenever you have a virtual image, you have an erect image formation. And whenever you have a real image, you always have an inverted or upside down image formation. So real image and virtual image are both the characteristics of a concave mirror, but for convex mirror, we are only restricted to virtual image all the time. For concave mirror, we could have real image, we could have virtual image, depending upon the placement of the object, where the object is being placed. So I hope this is clear for the real image, virtual image, and the image formed by the convex and the concave mirror. Thank you and see you in the next lecture.